This lesson covers standard SCP.9. From our textbook, it's lesson 10.1, day 2. We're going to learn more about permutations. Think about what 0 factorial is equal to. Yesterday we learned that a factorial is calculated by taking the number of the factorial, for example 5 factorial, and multiplying 5 times 4 times 3 times 1. But what if it was 0 factorial? We really need to think about what not just the mathematical calculation is, but what a factorial represents. And a factorial represents counting how many ways you could organize that list of numbers, or that list of items, list of objects. If you had 5 letters, for example, how many different ways could you organize those letters? Well, in this case, if you have 0 factorial, you have a set of 0 objects. How many ways could you organize that? 1. You'd have 1 way to organize it, and that would be the empty set. So, in general, the idea of factorial, it's used to compute the number of permutations of arranging a set of n numbers. So in this case, 0 numbers. So it can be said that an empty set can only be ordered one way. An empty set of nothing can be ordered one way. So 0 factorial is equal to 1. Let's look at an example. In contrast to yesterday's example where we had 9 players on the t-ball team and 9 places in our batting order, all 9 people were used in the grouping. We were organizing 9 people in a group of 9. But in this example, we have 23 people, hypothetically, playing in a mini golf tournament. Prizes are given for first, second, and third. So even though there's 23 people, we're only looking at listing or grouping 3 of them together at any given time. The 23rd person in the list is not going to get a prize. Neither will the 22nd or the 21st. It's only the first, second, and third. So this is more of a special permutation where order makes a difference. First prize is going to be a really big trophy. Second prize, a little bit smaller trophy. And third prize, smaller trophy still. So the order makes a difference, like yesterday. Also, repeats are not allowed. If you win first place in the mini golf tournament, you're not also going to win third place at the same time. So we need to keep those 2 ideas in mind. But in this case, we have a group of 23 people, but we're going to select only 3 at a time. So here's our formula for permutations of n objects taken r at a time. We look at it and it looks like NPR. So the formal calculation, the numerator is n factorial, so in our case 23 factorial. The denominator would be 23 minus 3 factorial. So we'd be looking at making this calculation of what's 23 factorial divided by 20 factorial. Should get 10,626 different ways that you could be giving out first, second, and third place in this mini golf tournament. With technology advanced as it is now, pretty much every scientific calculator will have a button that will allow you just to input the N, the P, and the R. So you need to be able to know your calculator well to find that NPR button. You'll have to input the 23 and input the 3 in the correct order. And test your calculator now to make sure you can find the correct way to put the numbers in to get 10,626. Let's take a look at this list. We have 3 letters, A, D, and D. And just for demonstration purposes, I made one of the D's red. So if we were thinking the number of ordered arrangements we could set up with these letters, you'd think, well, there are 3 letters there, 3 factorial. There should be 6 different ways to set up those letters. We could have ADD with a red D in the middle, ADD with a red D at the end, or DAD 2 different ways, or DDA 2 different ways. But really, if you look at it, a D is a D, no matter what color it is. So that bottom row of those words or arrangements is just a duplicate. So we really don't have 6 different arrangements. We really just have 3 because we have the letter D repeated twice in our group. So we're going to need a new formula that will remove those duplicates, if you will. And it isn't always just taking the original and dividing by 2, as you might think. Since the original list would have had 6, now we just see 3. We need to take a look at this and say the total number of letters, and then make sure we're able to remove the ones that are duplicates. Here's our formula for permutations with repetition. If we have n objects, where one of the objects is repeated s times, and there could be other objects that are also repeated, those repetitions are represented in the denominator. So in the example on the previous page, we had 3 letters, so we would have 3 factorial in the numerator, and the denominator would be a 2 factorial. That 2 factorial represents the letter D. The 2 specifically represents that there are 2 D's, and that calculation indeed gives us the correct number. There are really only 3 unique different arrangements of the letters A, D, and D. Let's try one a little bit more complicated. Take the word Mississippi, long word, 11 letters in it. Let's color code it. So with 11 letters, our numerator would be 11 factorial. Now let's start looking through. Well, the M is only in there once. It doesn't need to appear in the denominator. It's only the representations of letters that are repeated. The I in orange is in there 4 times. So I'm going to have a 4 factorial in the denominator. That whole factorial represents the letter I. The number 4 tells you that the I is in there 4 times. We see S is in that word 4 times. So 4 factorial goes in the denominator also. So this blue factorial is representing the S's. The number 4 says there are 4 S's. Lastly, we see the green letters, the P's. The green factorial represents the P's. 2 tells us that there are 2 P's in Mississippi. Carefully multiply this on your calculator. You're going to need to say 11 factorial divided by, and please make sure that you put parentheses around that denominator so that you are actually dividing 11 factorial, dividing by that entire 4 factorial, 4 factorial, 2 factorial. And that, set into your calculator correctly, should get you the correct final answer of 34,650 different ways you could set up your letters from the word Mississippi. Please now complete the rest of worksheet 10.1, problems 17 to 35.